Have you ever wondered if our Sun, the life-giving star at the center of our solar system, might have a twin? This is not just a sci-fi plot twist. It's an actual scientific hypothesis that has piqued the curiosity of astronomers and astrophysicists for decades. Welcome to the realm of the Nemesis Hypothesis, a theory suggesting that our Sun might have a companion star. This twin, christened Nemesis, was proposed to explain a rather disturbing pattern. The recurring mass extinctions on Earth occurring approximately every 27 million years. The hypothesis was first proposed in the early 80s by Richard Müller from the University of California, Berkeley. Müller suggested that Nemesis could be a red dwarf, a small and relatively cool star, located about 1.5 light-years away. According to him, this elusive twin could be the culprit behind the catastrophic mass extinction events we've seen in Earth's history. You see, the idea is that Nemesis, with its gravitational influence, could perturb the orbits of comets in the distant Oort cloud, an immense sphere of icy bodies surrounding our solar system. This would send a barrage of comets hurtling towards the inner solar system and Earth, causing mass extinctions. But if this is true, where is Nemesis? Why haven't we spotted this potentially deadly twin of our Sun? Well, the quest for Nemesis is like looking for a needle in a cosmic haystack. And it's not just about finding a small, faint star in the vastness of space. It's also about understanding how stars form and evolve, how binary systems, two stars orbiting a common center, come to be, and the dynamics of our own solar system. So the question remains, could Nemesis, the Sun's supposed twin, really exist? The quest for answers takes us on a journey through the cosmos, from the formation of stars in distant molecular clouds to the gravitational dynamics of our own backyard in space. It's a journey of discovery and understanding, of questioning what we know and exploring the mysteries that remain. While the existence of Nemesis remains a topic of debate, some scientists have offered compelling arguments in favor of this hypothetical star. Among these champions of the Nemesis hypothesis is Richard Müller from the University of California, Berkeley. Back in 1984, he suggested that Nemesis could be a red dwarf star, lurking about 1.5 light-years away. According to Müller, this star could be responsible for mass extinction events that seem to occur on Earth every 27 million years. But Müller is certainly not alone in his support. Enter Stephen W. Staller and Sarah I. Sadavoy, two researchers who've delved deep into the mysteries of star formation. Using the Van Dam project, they've studied young stars of Type 0 and Type 1, and their findings are nothing short of intriguing. According to their research, solar twins often form as binary systems. That's right, our Sun, as solitary as it seems, might have had a twin. Now you might be asking, where's the evidence? Well, look no further than the Perseus constellation. Here, astronomers have discovered 45 solitary stars, 19 binary systems, and 5 systems with more than 2 stars. Binary systems are common, so why should our Sun be any different? And then there's the Oort cloud. This distant cloud of icy bodies surrounding our solar system could be disturbed by the gravitational pull of a nearby star, such as Nemesis. This disturbance could send comets hurtling towards Earth, potentially causing mass extinctions. So while we may not have definitive proof of Nemesis, these supporting arguments certainly give us food for thought. The stars we see in the night sky might be hiding more secrets than we realize, and our understanding of our own Sun could be due for a cosmic shakeup. The evidence might not be concrete, but it certainly adds a layer of intrigue to the Nemesis hypothesis. If Nemesis does exist, then where is it? This is the ongoing conundrum that has perplexed scientists for decades. Despite the compelling hypothesis and the compelling evidence from stellar observations, Nemesis has remained elusive, hidden somewhere in the vast expanse of the cosmos. The primary challenge in locating Nemesis lies in the sheer vastness of space. It's like trying to find a needle in a haystack, except the haystack is light-years across and the needle is a potentially small star. If Nemesis is indeed a red dwarf, as Richard Müller proposed, its small size and dim light would make detection exceptionally difficult, especially if it is located as far as 1.5 light-years away from us. Another possibility is that Nemesis could be a dark object, such as a brown dwarf or even a small black hole. These objects, while smaller and darker than most stars, can still exert a gravitational influence which could be detectable by our modern instruments. However, their detection requires precise measurements and careful analysis, which is no small feat given the number of celestial objects that fill our skies. The history of astronomy is filled with examples of previously undetected celestial bodies that were discovered due to advancements in technology and methodology. Take Alpha Centauri, for instance. The closest star system to our own was discovered to be a triple system by Robert Innes in 1915. Before his discovery, we were unaware of Proxima Centauri, the third member of this system and the closest star to our solar system. So, while the search for Nemesis is challenging, it's not impossible. It requires patience, persistence, and a touch of luck. With the advancements in astronomical technology and our ever-growing understanding of the universe, we might one day uncover the truth about Nemesis. The search for Nemesis continues, but its existence remains a mystery. As our understanding of the universe evolves, so too do our theories about Nemesis. The classical Nemesis hypothesis, suggesting a dark twin star to our Sun, continues to intrigue us, yet it has also given way to revised theories that add new perspectives to this celestial mystery. One recent theory proposes a fascinating twist to the Nemesis narrative. It suggests that Nemesis may have indeed been a companion of the Sun, but not in the way we initially thought. Instead of being a dark, sinister twin lurking in the far reaches of our solar system, Nemesis might have been a friendly companion during the early stages of the Sun's life. It's like those friendships we all have had, which were once close but have drifted apart over the years. The theory suggests that Nemesis and the Sun might have separated a long time ago, each traveling independently throughout the Milky Way. This idea of stars typically forming with companions and later becoming solitary is not just a romantic notion. It's backed by scientific observations from the Perseus molecular cloud, a massive star-forming region located about 600 light-years away from us. Here, researchers have found that young stars, much like our Sun, often start their lives with a partner. Over time, many of these binary systems break apart, with each star heading off on its own journey through the cosmos. So could the Sun have once had a companion that we now know as Nemesis? Could this companion have drifted away, leaving our Sun to shine alone in our solar system? These are exciting questions that continue to drive our exploration of the universe. Yet, despite these new theories and the compelling evidence from the Perseus molecular cloud, the existence of Nemesis remains a mystery. We're still waiting for that definitive piece of evidence that either confirms or refutes the Nemesis hypothesis. While these revised theories provide new insights, the question of Nemesis's existence remains unanswered. While the search for Nemesis continues, other celestial phenomena provide fascinating insights into the dynamics of our solar system. For instance, the star Gliese 710 is on a trajectory that will bring it close to the Oort cloud. This encounter could potentially send objects hurtling towards the inner solar system. Now, this isn't necessarily a sign of impending doom, like the dinosaur extinction, but it certainly adds an interesting layer to our understanding of solar system dynamics, and it is this relentless pursuit of understanding that drives scientific progress. Every celestial event, every distant star, poses questions that can lead us to new discoveries. This constant exploration is fueled by the necessity to understand potential threats from celestial objects, regardless of their current existence. Shifting gears to the realm of giant planets, let's talk about Jupiter. This gas giant is intriguing because it radiates more heat than it receives from the Sun. This disparity has sparked speculation about past nuclear fusion activity within Jupiter, but the plot thickens when we consider Saturn, which, despite being smaller than Jupiter, emits even more heat. This contradicts the assumption that a larger mass should result in more emitted heat, adding yet another layer of complexity to our understanding of planetary dynamics. Diving deeper into Jupiter's structure, we find a fascinating mix. The planet's interior consists of various layers, including a gaseous atmosphere, a layer of liquid hydrogen and helium, a layer of metallic hydrogen, and a core whose composition remains uncertain. As we explore these celestial phenomena, one fact becomes abundantly clear. Our understanding of the universe is always evolving. Each new discovery, each revised theory, brings us one step closer to unraveling the mysteries of the cosmos. And while the existence of Nemesis remains a captivating question, it's just one piece in the vast cosmic puzzle that is our universe. These celestial phenomena remind us that our understanding of the universe is always evolving. So what can we say about Nemesis, the supposed twin of the Sun? Well, the Nemesis hypothesis certainly presents a fascinating potential explanation for Earth's periodic mass extinctions. This theory suggests that our Sun might have a companion star, Nemesis, lurking somewhere in the vast cosmos, disturbing the orbits of comets and asteroids every 27 million years, which in turn cause mass extinctions on Earth. Proponents of the theory, such as Richard Müller, have gone as far as to suggest that Nemesis could be a red dwarf star located about 1.5 light-years away. Observations from the Perseus constellation and the Van Dam project indeed indicate that binary systems are common in the universe, yet our Sun seems to be an exception to this rule. However, it's important to remember that the absence of evidence is not evidence of absence. The elusive nature of Nemesis could be attributed to its small size and great distance from us. It might be a dark object, perhaps a brown dwarf, or even a small black hole, which could still exert a gravitational influence detectable by modern instruments. The revised theories propose that Nemesis may have been a companion during the early stages of the Sun's life, but later separated. Observations from the Perseus molecular cloud support this idea, suggesting that stars typically form with companions and later become solitary. In the grand scheme of our understanding of the universe, the Nemesis hypothesis, whether proven or disproven, continues to have a significant impact. It prompts us to question, to explore, and to push the boundaries of our knowledge. It reminds us that the universe is full of mysteries waiting to be unraveled. As we continue to make strides in science and technology, our understanding of celestial events and objects is ever evolving. The quest to find Nemesis, the Sun's lost twin, is an ongoing journey. The existence of Nemesis remains a tantalizing possibility, and who knows what future research may reveal.